Good morning, students. Happy good morning. Welcome to online classes. The subject today EE 304C C18 scheme, electrical and electronics measuring instruments, in that single phase energy meter. Have you observed what is this one? Okay. So before going to tell it, recall what we have seen in previous classes. Okay. Now this topic is regarding to this one. At the same time, my sincere thanks and courtesy to all authors for sharing valuable materials in internet. At the same time, my sincere thanks to Gnana Prasanna, senior lecturer in Government Polytechnic, Visakhapatnam. She has helped to develop these total slides. Thanks, madam. Today, objectives. On completion of this period, you would be able to know first one, the principles of operation of single phase induction type energy meter and its construction of single phase induction type energy meter. Now, known to unknown. What do you mean by what is energy? First of all, energy is the total power delivered or consumed over a time interval. What is that one? In previous classes, we have seen that instruments are classified, secondary instruments are classified into three types: indicating instruments, recording instruments, and integrating instruments. The integrating instrument example is the energy meter. It integrates the values from a given period. Okay. So, energy is the total power delivered over a given interval of time. Okay. So, what is the unit of energy? So, that is the joule for watt seconds, or we can say that kilowatts hour, or we can say that kilowatt hour. Okay. So, before entering into our energy field, let us recall what we have seen in previous classes regarding to our energy measurements. Okay. Now, as we know that to measure the current, so we require the, for example, it can take, this is the one circuit. Okay, one circuit where it is connected one ammeter, and here I connected one bulb load, and here I connected one circuit. At the same time, I connected the one voltmeter here. Okay. So, what is happen? When switch is closed, automatically the current will pass through this circuit. For example, plus minus, you can see the 220 volts DC. Then the current will pass through this one, and how much current is flowing in the circuit is given by the our ammeter. Okay, it will give us what is the current and what is the voltage drop occurred across our bulb, incandescent lamp. It indicated by the our voltmeter in volts. Okay, so this is a simple circuit. And coming to the AC circuits, for example, same circuit I required if I connected the AC supply, so or AC supply. Now it is connected here, and I connected the one ammeter, and it connected one wattmeter also connected here, and here connected to one bulb. Similarly connected another bulb also. Okay, so the bulbs are connected in parallel, for example. Now connected here. Okay, bulbs are connected parallel. Now it is connected here. Now I connected the one, for example, I connected the one voltmeter across the load. This is the ammeter. Okay, so when switch is closed, the current will passing through this one. This is the ammeter, this is the wattmeter, this is the voltmeter. Now once switch is closed, the current passing through the circuit and bulbs will glow. Okay, then I want to know that what is the current taken from the supply. For example, this is the 230 volts AC supply. Then I can easily know with the help of my ammeter. Ammeter will measure the what is the current flowing in the circuit. Then our wattmeter will show the what is the power consumed by these two bulbs. For example, this is the 60 watts bulb, this is a 100 watts bulbs. Okay, so this total 160 watts indicated by the wattmeter. Then what is the voltage? Actually here 230 volts applied. What is the voltage across this one? It indicated with our voltmeter. So here I know the current, I know the voltage, I know the watts by using our this voltmeter, ammeter and wattmeter. Now I want to know that what is the energy I require. Energy. So this is voltage, current, power. I require the energy. So how to find the energy? So as an electrical student, you know that what is the power? Power is equal to V into I into cos phi in case of AC supply. Okay, now I want the energy. So what is the energy? Energy is equal to P into D, nothing but this is the time period. So I can write it V into I into cos phi into duration, time. Okay, this is the time measure. Then I can get the energy in watt hour, the unit. Here what is the unit of voltage? Volts. What is the unit of current? Amperes. What is the unit of power? Watts. Similarly, what is the unit of this one? Watt hour or joules per second. Okay, so these are the basic things. Now one doubt, in laboratory I have the wattmeter and voltmeters and ammeters you have observed while doing experiments in our laboratories. For example, in electricity board, for example, you can take the discom people. So they will give the supply. So nearby our house, okay, there is a one PSC poles, current pole. Okay, it has a one insulator, there is no another insulator. Two lines are, for example, you take it. Now I have the my small house. Okay, so I require the one fan, I require the one tube light. Okay, and at the same time I want to give the connection this one. So that's why what will happen? So I will approach the current electricity department people I can apply the form A and I will take the connection. Then what will happen? He will come, he will take the one service wire and given to the our connection. One is a phase and is a neutral in service wire, and given here 1 meter is connected initially in our premises. So what is that one? That is known as the energy meter. Based on this energy meter, so we are going to pay the bill. So every month we are paying the current bill. So how many units you are consumed in a given 1 month? Based on this, you are going to pay the current bill. Okay. So how it can measure? How it will measure total units for given 1 month? So sometimes we can use a fan, sometimes we can use a tube light, and sometimes we can use the charging of our cell phones. Different times we can operate the different applications. Okay. So this all thing observed by our God. Who is our God here? Energy meter. Okay. Energy meter. How you are going to doing your works, whether you are going to concentrate your mind on your studies, or you are simply you are predicting, or really you are working, that can be observed by our God. Similarly, in our house also we have the one instrument that can observe when all these operators, whether it is a working or idle condition. But the God is a real one. He will only take the readings once our operator is in live only. Okay. So based on this consumption by our tube light, our fan, our chargers, etc., taken by this our energy meter, and that will total adding all our electrical power in a given time, and at the end of the month it will pass to the whatever the energy consumed by our house to concerned people. So based on this reading, they will give the how much we have to pay the tariff bill to that one. Okay. So that is a energy meter. Okay. So what is the energy? Okay. Once again, so energy is the total power delivered over a given interval of time. Okay. So its a unit is the kilowatt hour in bulk time, or otherwise we can use the watt hour. Okay. So this is an integrating instrument which measures a quantity of electric energy supplied to a circuit in a given time, as we have seen in previous classes. Okay. Indicating instruments indicate the value at that instant. Okay. Recording instrument that indicate the recording value at that given period on a graph, whereas our energy meter is the integrating instrument, integrate the total units from month starting to month ending. Okay. This is our energy meter. I think everyone has observed this machine, this motor, sorry, you can say that this is a meter in our premises. Okay. So now I am going to tell something about this energy meter. Okay. So let us see, this is a what is energy meter, how it will works, what are the different parts of energy meters. Okay. So now what is an energy meter? An integrating instrument which measures the quantity of electric energy supplied to a circuit in a given time. Okay. So this is the energy meter. Olden days, these are the used, and after some previous 5 years or 10 years before, this is another modification taken place. This is another one. Nowadays you cannot observe this type of the energy meters. So you can observe the latest one, China meters, where it has no disc to rotate inside, or electronic energy meters. Okay. So basic thing is the analog energy meter. Let us see this basic analog energy meter. After that we will consider the electronic energy meter also. Okay, so our aim is to what are the different parts inside a energy meter, how it will measure the current, how it will measure the voltage, and voltage and current and time and power factor will give the energy. After measuring the energy, how it will integrate the time to time these units. Okay, so we will see that one. Now, so what are the benefits of these energy meters? So as we know that moving iron instrument, moving coil instruments, okay, the watt meters also, dynamometer, watt meters also. So we have the some merits and demerits of those meters. Similarly, so we have the some merits of these energy meters. What are the benefits of these energy meters? So mainly this energy meter is an integrating instrument, is a lower in friction in while rotating in disc, higher torque by weight ratio, and it is a cheap and best instrument, and it will give the accurate values, and at the same time retain the accuracy over a wide range of loads, at the same time temperature conditions, whether any atmospheric conditions it will give the its accuracy. Okay, so these are the some benefits of energy meter. Now you can see, so it is a lower friction in rotating instruments disc, and higher torque by weight ratio. It is a inexpensive, cheap and best, and accurate. It will give the units. Otherwise, what will happen? There is a disputes. There is a war. What will happen if the same energy meter for the same load for 2 houses, one fellow is having the units of 25 units, another fellow maybe 45 units for the same single tube light, single fan. But is one person is reading as a 45 units, one person having the 25 units. So this is a mal-operation of energy meters, but it will give the same values for the same duration of operation of our appliances. So that is the required the, so if what will happen, sir, if some meters will rotate the speed, then automatically units will takes place more. At that condition, there is a RSS meter, substandard rotary meter will measure the, calibrate the whether it is running correct or any error that can be adjusted in NPTCL bench. Okay, so that is another experiment we are going to do in our laboratory with using RSS meter. Okay, so now let us assume all energy meters are, so will gives the accurate reading. Okay, sir, there is a one reason, one doubt. Sir, will it possible to change the rotation of disc if disc is rotating more number of times? So disc has some rotations. So what is that? It has a constant. So for example, you can take this. For example, this having the one energy meter. Okay, this is energy meter is connected. The phase and this is a neutral, and this is the phase and neutral is connected, and based on this one, and the disc will rotate. Okay, this is my for example one A energy meter Oz. For example, another energy meter. So here you can take the another energy meter, my neighbor. So same, he has the phase and neutral, phase and neutral, and same the units is one, and is also rotating. So I have the one fan, I have the one bulb. Okay, so I have the one tube light, for example. Similarly, E also same load. Okay, so we both are employees in a private sector. So he will leave the house at 8 o'clock, similar to myself, and he will come at evening 6 o'clock. Same, I am also same thing. So I can use this all same times. So fan will used 4 hours, or sorry, it may be 8 hours, and light also 6 hours, it may be 2 hours. Similarly, is also 8 hours, 6 hours and 2 hours. But at end of the 1 month, I am going to get is my reading, the units consumed here. Unit consumed is 45 units. 45 units. But this person, luckily, he got is only 35 units only. Then what is happened? So I have to pay the corresponding this units. For example, unit 2 rupees, I have to pay the 90 rupees for month. He has to pay the RS only 70 rupees for month. What is the difference? 20 rupees is the difference. Okay, so it is not good. It is a mal operation of the energy meters, because I have the same load, I am using the same time, but my energy meter showing the more number of units, and that fellow having the less 35 units. Maybe one of the meter is correct. So maybe his meter is running slow, my meter is running speed. Otherwise, so my meter also running high speed. So that's why, so what will happen? So I can approach to the one friend just like you as a diploma student. I can, so where is a department person? I requested these things. So by taking my consideration, so he has some changes takes place inside our meter. Okay, then what will happen? So automatically in next month I am going to get only 25 units for the same operation, but this person may be getting the 35 units only. Then what is my cost? Only I have to pay the 50 rupees. He may get the 70 rupees. Okay, sir, it is possible? Yes, it may be possible. How? Because in this case, I can, my rotation of disc, I slowered, I decrease the rotation by changing internal arrangements. Okay, there is a one permanent magnet inside the braking magnet. So I have applied the more brakes to my disc rotation. Then automatically it will run very slowly. That's why I am going to get the 25 units only. But the poor fellow, he has to pay the only that 35 units only. But it is not fair. Okay, so I can change the rotation of a disc. So whether this correct or this correct is decided by the RSS meter. Rotary substandard meter will measure the, calibrate the meters exact, what is the exact values. Okay, so that is another way. Okay, so don't bother about that thing. So let us enter our topic. Now these are the some merits. Okay, so after the merits, so now let us see the what is the basic principle. Okay, so what is the principle? In induction instrument, deflection torque is produced due to reaction between two buses. So how the deflecting torque is developed in indicating instruments? So whether it's a input sources, whether it's a voltage, current, power, chemical energy, electromagnetic energy, any type of the energies try to produce a deflecting torque. This deflecting torque always opposed by controlling torque and damping torque, already we have seen. So in this case, how we are going to produce the deflecting torque? Okay, there is no pointer inside. Here is the disc is inside. Our aim is to rotate the disc, to move the disc. Okay, so that purpose I require some deflecting torque is required to rotate our aluminum disc. That purpose, in an induction instrument, the deflection torque is produced due to the reaction between the flux of AC magnets and eddy current induced in a metal disc. What is meaning? Now, what is that means here you can see. So, what is happen in our normal instruments, there is a pointer. Okay, the pointer is a pointer. To deflect the pointer from 0 to these values, I require some torque. The torque is called deflecting torque. Okay, at the same time, what will happen? This will opposed by the 2. The deflecting torque opposed by one is the controlling torque Tc and opposed by the damping torque damp. Okay, whenever the deflecting torque is equal to Tc plus T damping, then pointer is stable. So already we have seen. But in our energy meter there is no pointer. Then how the deflecting torque is developed? Only our aim is to rotate the disc. This disc has to rotate. Okay, then it will measure here. So how the disc will rotate here? So that to rotate the disc, it is a aluminum disc, simply aluminum disc. It has to rotate. Then how the deflecting torque is developed here? So there is an interaction between the one. So what is happened? Here is a two magnets we are providing. Okay, here is a U. So this is a M1 magnet. And this is a M2 magnet. In between there is a, I am providing the one aluminum disc. Okay, so aluminum disc, what is happen? So it producing the flux. It producing the flux to magnets. Due to these two magnets, so the disc is a nothing but aluminum disc. Aluminum is a good conductor, and due to the magnetic field of this electromagnets, there is induction effect and it produces the eddy current inside the aluminum. And this eddy current, because aluminum disc is this one. Okay, now what will happen? EMF induced as per the Faraday's laws of electromagnetic induction. And aluminum disc is a closed path, then current will produce. Due to the current, it also produces its own magnetic field. This is known as our Ganesh Vinayaka. Okay, so this is nothing but Shiva. Okay, this is a father, this is the son. Always there is a war between the Shiva and Vinayaka. Okay, that means, so due to the Lentz's law, so what will happen? Always opposes cause of its production. What is the cause of its production? So here the cause is the magnetic field. This electromagnetic fields opposes the produce the flux. There is an interaction takes place. Then rotor will rotate in one direction. Okay, so such a way that a deflecting torque is produced here. The deflecting torque is produced due to the interaction between the flux of an AC magnets. Here this is AC produced electromagnets and EMF induced, that is the eddy current induced in a metallic aluminum disc. So this magnetic flux, our Vinayaka or Ganesh, and this Shankara, that is the magnetic field, interaction between the father and son, the war. Then what will happen? So always all gods support to the only father only, but only alone our Vinayaka. That's why what will happen? So we are placed bearings inside. That means we are not supporting the sun. Meanwhile, we are placing the some oil nearby its foot of Vinayaka. Then automatically what will happen? So automatically the sun will automatically lose its war. So then rotor will, the interaction between this flux and this flux, the rotor will rotate in one direction. Okay, So, sir, whether it is possible to rotate this disc, for example, it is rotating this direction. Is it possible to rotate this direction also? Why not? We can rotate also. That means, so here there is a your dot. Sir, it is a, for example, it is rotating this direction. Then it is the readings are, it is going to the 1, 2, 3, 4, 5, it is a increasing this value. Okay, for example, if I having the knowledge, if I rotate the rotor this direction, so it will comes to the decreasing, sir. So instead of already I got the 45 units, if I rotate this direction automatically, so what will happen? This will comes to the 44, 43, reduce the value. It is possible? Yes, it may be possible. That's why what will happen? Simple electromagnets. The current passing through the coil this direction, it is rotating torque this direction. For example, if current is passing through this direction, then automatically it will rotate this direction. That is a basic principle. So whether rotating this direction, it will, if it rotate this direction, the value is integrating, it is a reading value increases. If it is rotating this direction, the value will decrease. Simply this is a mechanical gearing system. So due to your over knowledge, so the people, the technical people, there is a one knob is provided inside. If try to rotate, give the connection reverse direction, it will stop to rotate this direction by placing one hurdle inside the energy meter. So that's why there is no use. Okay. So there is a one possibles. While I am doing as a sub-engineer in APACB at the time of 1997 to 99, I can inspected some places with my divisional engineers and additional engineers to the rural areas, where some of the technical fellows, the people, so what will happen? So what will happen here? The reading is reading and the disc is rotating here. There is a glass is provided here. Okay. So what will happen? They will give the connections, because here they will give the, so this is a sealed, by using the lead we seal this. So it is offense to open this one. Okay. So whatever the current enters goes and it will goes here. Based on this load current, it will rotate. So what will they will do? That they will use a one film reel, just like is the X-ray, just like you can use the X-ray, that can be used in eclipse time. We can use this also. So what will happen? They will use this small piece of this X-ray or film. They will insert from the glass to inside here. Inside, what will happen? So while disc is rotating this direction due to the deflecting torque, they will insert this is the film inside. What will happen? Once it touches the disc, so this deflecting torque is very less. Once it is touching to this one, what will happen? There is a friction between our film and our disc. Then automatically disc will rotate slowly. Then what will happen? So even if you are using the more load, our reading will be very less. Okay. So once the APSB people try to inspect the meters, they will know before that one, they will simply taken out. So taken out, then what will happen? So it will comes to the outside, then disc will rotate. Then there is no evidence to checklist. That is one method. So we found many places just like in villages. This is a offense, and some people will do another way also. What will happen? So here the energy meter, they will use the energy meter this same time. So they will use a disc will rotating here. Okay, disc will rotate here, and they will use. So what will happen? This is a phase is connected here, neutral is connected here. and here the phase is going here, neutral is going here. Okay, so sometimes they will, what they can do, they will break the seal here, then directly they will take the from phase to, and this phase is given. That means here whatever phase is coming here, inside will goes to here and is coming here. So they will use a direct bypass to this one. Then what will happen? Whatever the current is coming, some of the current is flowing here, some of the current is flowing bypassed here. Then automatically the reading will less. But so you can easily find so whether the seal is breaked or broken or not. If found it, there is a penalty nearly 5,000 to 10,000. That also we have done. And some fellows, so they will drill the small drill the top of the energy meter here. So they will use a small ball pin, something pin. They will try to place here to avoid the rotation of this disc also. That is another method. Okay, so these are the different types of mal operations they will try to do, but nowadays there is no chance. So all the disc rotation is absolute. Now we are going to get is only electronic devices, no rotation, mechanical rotations. Now a digital meters. Okay, so digital meter will, there is a rotation of disc. So this is all information, dear students. So that means whether it may be possible to slow the rotation of our disc, or whether it may be possible to rotate the reverse direction. That can be possible in practically, but it is not it's not a fair. Okay, coming to our topic. Now after that, so what are the different systems present in a energy meters? Okay, so if we are going to, so nowadays we are using this time. So you can see here, where is the disc here? No disc, the China meters. Okay, whatever the value is given to the phase and neutral, and phase and neutral is given. Okay, so there is a seal here also, and simply it will take the reading. Nowadays what will the fellow will comes just by using the IR, and without noting this one, by placing simply by the meter, it will take the reading directly. Okay, now so what are the inside? If we enter inside, if I open the this body, our energy meter, what are the different systems present inside? It is a digital. I want to analog, where the disc is present. Let us open that analog single phase energy meter. So mainly the construction point of view. Okay, so mainly construction point of view, it consists of, so you can see this energy meter. Okay, so this is a different energy arrangements. What is that? It has a driving system. It has the driving system. First of all, it has a more the main parts are the, one is the driving system. It drives the disc, and moving system, and braking system, and registering system. These are the four systems present in a analog single phase energy meter. Okay, so driving system, moving system, braking system, and registering system. What is different of this one? We will see. Okay, now so if we want to see the open also, so where this is a driving system, so driving system is nothing but here this, you can observe, dear students, there is a disc here, you can see it, disc here. This is a registering system. Okay, so driving system, you can see the drive deflecting torque produced. So there is a coils presence inside. Okay, we will see that one. Okay, there is a braking system also here, also one permanent magnets also provided here. Okay, we will see in details. Now you can see this is a fully open system, where it has the driving system and moving system, braking system and registering system. So, here is the resistor system. This is the resistor system. Okay. There is a braking system using the magnets, brake magnet. Okay. This is the aluminum disc. There is a two electromagnets, the driving system. Okay. So, these are the different type of the systems present in single phase energy meter. Let us see driving system. What is meant by the driving system? The driving system consists of two electromagnets M1 and M2. That means here this is known as the M1 electromagnet, this is known as the M2. Okay. So, here in electromagnets M1 and M2 two electromagnets. Here we can say M1 is the current coil and M2 we can say the pressure coil, similar to the wattmeters. At the same time, there is a one copper shading band also provided in M2 in center limb. So, M2 just like previously we have seen, this is the M2 and U shape, this is known as the M1. Okay. So, there is a copper band and there is a winding also provided on it. So, this is the winding connected here directly and here one winding is connected here through load bulb. You connect the bulb and we are going to this one. Okay. That means here whatever this upper magnet M2 magnet simply connected the phase, this is a neutral, connected in parallel coil. So, that is why we can say it's the pressure coil. The pressure coil is placed in M2 and now we can see this is connected through the load series coil. This is the M1. In between there is a aluminum disc, you can see this one. Okay. It has the two electromagnets, one is a M1 and another is a M2. The M1 consists of current coil, the current coil consists of a thick diameter, that is a large diameter, turns, less number of turns, whereas the M2 consists of the large number of turns with a thin wire. Okay. Copper shading band also small short circuited copper ring is provided on the center limb of the M2 coil. Okay. Now, we can see the current coil, pressure coil and copper shading bands. Now, electromagnets. So, these are the M1, M2 are the two electromagnets. What is the meaning of the electromagnets? Whenever the electrical supply available in the coil, it acts as electromagnets. If there is no current, it is simply one copper coils. Okay. Now, electromagnets. The core of the two electromagnets are made up of silicon laminations similar to our motors. What is the purpose of this one? Is to reduce the core losses. The core losses are eddy current losses and hysteresis losses. Hysteresis losses can be reduced by using the high silicon content material and eddy current can be reduced by laminations. What is the lamination thickness? Generally 0.35 mm to 0.5 mm thickness generally used in our electrical machines. Nowadays we are using the amorphous core also, it has a just like paper thickness. So, our aim is to reduce the iron losses, unnecessary iron losses. Iron losses depend upon the voltage. Okay. So, that is why we are going to try to laminate by using the good ferromagnetic materials. Okay. So, what are they? So, series magnet M1 excited with the line current and shunt magnet M2 the winding connected across the supply. Okay. So this M1 and M2 already we have seen. Now you can see that if this is a practical energy meter, if you opened, I want as electrical student, I want to know the circuit diagram, how it is internally connected. I cannot know. So you can see here, dear students. So this is a you can see here. So you can observe this is a coil, M1 coil, turns you can see less number of turns but thick wire. So you can see this is a coil M2. Okay. So this is a M1, this is a M2. Now you can see our electrical circuit of this instrument. This is the instrument. What is inside? You can observe here. This is the copper band. Where is the copper band? So you can see this is a copper band. Okay. Now copper band is placed here. So you can see here also copper band, here also copper band sometimes. So this is a shunt magnet, upper magnet, and this is a winding. This is a pressure coil to know the voltage, and at the same time this is a series coil to know the current. The series coil connected in series with the load. You can see here load, L is the load. Okay. These are our electrical connection diagram of a single phase energy meter, and you can see this aluminum disc here. Okay, placed in the bearings. There is a spindle, lightweight spindle. Okay, so this is the parts of a energy meter. Now let us see what is the current coil. This is the current coil. This is the voltage coil or pressure coil. What is the current coil here? Now you know that this current coil, about this current coil. The coil wound on series magnet M1, the alternating flux phi1 produced. This is produced by the phi1. Whenever the current is flowing through the coil, it produces the flux. That flux is represented as a phi1, and the phi1 is directly proportional to load current. If the load is more current will flows, then more flux will develop. That is the load current, nothing but load current. And this flux is in phase with the current, load current. Okay. If the current is more, flux is more. This is one angle, this is the same angle, in phase with the current. Okay. This is the thing. Now coming to the pressure coil. Now coming to this pressure coil. So what is the pressure coil? The coil wound on the shunt magnet M2. Whenever the current is passing through the pressure coil, it produces the flux. Okay, so that flux. So for example, you can take the flux is produced by this is phi2, and this phi2 flux is directly proportional to voltage. Voltage, this is connected across. So you can see this is connected here, and another terminal is connected to this coil. One is this here, and is connected here, is connected to this neutral. So here you can see here. Okay, it's connected here. Here it connected. Sorry. Okay, so that means whatever the flux, the phi2 is directly proportional to voltage. If the more voltage, more flux. Less voltage, less flux. And this flux, whatever the flux, lagged by 90 degrees with voltage. Suppose voltage is this direction, the flux, whatever the flux phi2, this direction. So this is 90 degrees try to maintain. If it is not 90 degrees, that can be adjusted with the help of this shading rings. That is the help of the shading rings. They are achieved by the copper shading bands. So with 90 degrees between the voltage and the flux produced in the magnet M2. Okay, so this is the things. So what will happen? The flux produced in series is the phi is directly proportional to the load current, and this flux and this current are the in phase. Both are the friends. But whereas in flux produced in this magnet, the one friend is this direction, but another friend is this direction. Both are 90 degrees apart. Okay. So, this friend is dependent upon the voltage, this friend is dependent upon the current. So, both are in phase, they are the very good friends. But in this case what will happen? So, in this whatever the phi 2 produced due to the voltage, but the phase angle is the 90 degrees. So, this exactly 90 degrees can be adjusted to produce the deflecting torque. That purpose I can use some additional shading rings here. By adjusting the position in shading rings. The shading rings is nothing but is a copper winding, just like the copper ring. What will happen once you can see copper shade. So, what is that? Suppose you can see one copper, this is a magnet, flux is produced. If you are producing the one copper ring here, it links with the magnetic field. What are the magnetic field? Then what will happen? It is also produces its own flux. Okay, this flux and this flux interaction takes place. Then what will happen? So, there is a possible to reduce this main flux one direction. That is why, so what will happen? We are going to get that the flux produced by this is the voltage and this is the flux produced the phi 2. We can reduce the 90 degrees. We can try to produce. Okay, that is the benefit of shading ring. So, what is the copper shading bands, or we can say this is also power factor compensator. We can say this is also power factor compensator. Provide on center limb, and sometimes we can use ear also. The position is adjustable. We can move this up and down. We can use the up and down. We can easily move the up and down. Based on the movement, we can adjust the angle between the voltage and flux produced by the voltage coil. Okay. Main function is brings phi 2 in quadrature with the applied voltage. Okay. So, dear students, just you remember that thing. Okay. So, these are the coming to the driving system. Now, the coil, current coil owned on the series magnet M1, and the alternating flux phi 1 produced by it is and proportional to the line current and in phase with the line current. Both are the good friends. In the pressure coil, what will happen? There is a dispute between the two fellows. So, coil wound on the shunt magnet M2 and flux phi 2 is produced by it and is proportional to the voltage, and it lags behind the supply voltage by 90 degrees. If it is not 90 degrees, we can achieve by the copper shading ring. Okay. Copper shading bands, or we can say the power factor compensator. So, similarly, the provided on central limb and the position is adjustable. We can move the up and down some in a central limb to get the 90 degrees between the voltage and phi 2. So, main function is placed in the brings phi 2 in quadrature with the applied voltage. Okay, coming to the another system, so moving system. So, it consists of a aluminum disc. So, what is the moving here? Only in this case, in total energy meter, only this aluminum disc will move. Remaining all are stationary. The flux is produced, but we cannot see that one. Physical movement in a energy meter is only aluminum disc. Aluminum is the conductor. Okay, it consists of an aluminum disc. Disc is mounted on a light alloy shaft. Just like you can see this, one shaft is provided here. Light weight shaft placed in the air gap between the series and shunt magnets. So, you can see this is a shunt magnet, this is a series magnet, that is M1, M2. You can see it. The aluminum disc is placed in between the M1 and M2 and connected with a light weight alloy shaft. You can see it. And the shaft is placed on some bearings, and one side is connected to the recording counters. Okay. Now, the moving system, it rotates on a steel pivot. Pivot is provided and here also. Okay, pivot is provided. The pivot is screwed to the foot of the shaft. A pinion engages a shaft with a counting or registering mechanism. You can see this is one pinion is engages. Okay, so coupling, that is records the how many, suppose that means for example 250 rotations RPM, then it will take the 1 unit, it will move the 1 digit. Okay, so whatever the digits here, the this one, so 0 0 1. So after 250 rotations of disk, then it will comes to the 2. After 250 rotations remaining, then it will comes to 3. Such a way that there is a mechanisms provided in the resistor system. Okay, so that is a mechanical system. Now, the moving system consists of an aluminum disc. A disc is mounted on a light alloy shaft and placed in the air gap between the series and shunt magnets. The moving system also consists of a rotates on a steel pivot. The pivot is screwed to the foot of the shaft and a pinion engages the shaft with a counting or a registering mechanism. Okay, so these are the some regarding to the moving system. Now, rotor is rotating, disc is rotating. I want to reduce its speed, I want to increase its speed. How can I change it? By calibration. By calibrating on a substandard meter, I can fix the speed rotation. That purpose I require the braking. So every vehicle require the brakes, otherwise there is a possible to accidents. Similarly, our driving system, that is a moving system, also require the one braking system. That's a controlling torque, nothing but. The controlling torque is required. The damping torque also required. Okay, to oppose the deflecting torque. That is the braking system. So in braking system, it consists of, so you can see in this figure. So there is a braking magnet. This is the braking magnets, brakes, electromagnet. Permanent magnet. Dear students, if you open the energy meters, there is a magnet present inside. The U-shaped magnet presents inside. Sometimes we can use the two magnets. Sometimes we can use a single magnet. Okay, so you can see then the figure. What is this one? This is known as the series coil. This is known as the pressure coil, M2. And at the observe, this what is the thickness of this one? What is the thickness of this one? Okay, so now this is the aluminum disc is placed in a light spindle placed in pivots, and it's provided the mechanism. You can see this is a one resistor mechanism also provided. Okay, now the what is the braking system? It consists of two permanent magnets called braking magnets. So here is the one magnet. Sometimes we can provide the another magnet also here. They are placed diametrically at the edges of the aluminum disc. That means, so this disc is presented. If you are placing one disc here, another disc also we are provided here, not side by side. So if you are putting the one disc here, another permanent magnet, it is not. So you have to provide. So it is provided at diametrically opposite at the edges of the aluminum disc. Okay, aluminum disc moves in the field of magnets. What will happen? So here you can observe thing. So here is a one. Here, and at the same time this one. Now one aluminum disc is here. Okay, so what will happen? So due to the this is north, for example, North Pole, south pole, north pole, south pole. Okay, then what will happen? There is a magnetic field, north to south magnetic field. Then once at stationary position, this magnetic field induces flux in this one. It is possible? No, because the flux is constant here. Disk is conductor here. So, where is the relative motion? Relative motion is 0. No EMF induced in the disk at initially when the disk rotation is 0. If disk rotates, at that condition the disk will cut the stationary magnetic field. Whenever the conductor cuts the magnetic field, it induces EMF in the conductor. What is conductor here? Disk. Then, so due to the cutting of magnetic field of the stationary magnetic field, then EMF induced in the disk. This induced EMF, because the disk is a closed one, this is a conductor, then automatically once EMF induced, it produces the currents, it produces the flux, own flux. Once again, there is a small Vinayaka. This is a at the same time Shiva. Okay, this is a Vinayaka. Always there is a quarrel between the father and son. Then what will happen? So this whatever the flux produced in the disk always opposes cause of its production as per the our Lenge's law. Okay, Lenge's law. What is the cause of its production? Rotation. So here if there is no rotation, just like you can see, dear students. So there is a one person here standing here. There is a one dog also here. Okay, dog also here. The dog is trying to chase this person. He is standing. The dog also stands. If it is moving, then it will try to catch him. If it will stop, it will stop. If it moves, it will move. So there is a possible to bite when it's running condition only. Similarly, only EMF induced in the disk when disk is rotates. So this cause of its production is the rotation. Then whatever the flux is produced is always opposites the rotation. Then automatically rotation will reduce its speed. That is the braking. Indirectly we are applying the braking. Okay. Now let us see this one. It consists of two permanent magnets called braking magnets. They are placed diametrically at the edges of the aluminum disc. Aluminum disc moves in the field of magnets. What will happen? If moves, automatically induces a EMF. Aluminum disc provides the braking torque. The position of permanent magnet is adjustable. Here you can observe one thing, dear students. What is that one? So suppose for example, here is a aluminum disc. Okay, this is aluminum disc. I placed the magnet here. What will happen? So magnetic flux cutted position. Sorry, you can see another. You can see. Okay, what will happen? The disc is, for example, this is the disc. Okay. Now I placed the magnets here. Braking magnets placed one side here. Then what is happened? So what is the magnetic lines of forces here? This is the flux linkages. In second case, so I can use, now same disc is provided here and I can use at the edge only. Okay, then what is happened? At the edge only. So this is a portion is cutted. Okay, here the more portion, that means a length, you can say disc is here, disc is here, is a linked flux. So linked flux is a more linking flux here. Here is less linking flux here. The more links, what will happen? The deflecting torque, the braking torque is more, That's why it will apply the more brakes here. Braking force is more. Okay, so because more flux linked, more EMF induced, more flux produced, then it will oppose the cause of its production, rotation. Then what will happen? The speed will break here more. Whereas if the moving this, instead of here placing, I can move my magnet outside. So less the interaction of this aluminum frame. Then what will happen? Less flux is linked with one, cutting it one, it produces a less flux. That less flux due to the less torque is produced. The torque, braking torque is less. That's why it less opposition to the rotation. Then here braking system is less. Okay, that means by moving our magnets inside and outside, I can change the braking power, our braking torque, that is a controlling torque, or we can say the adjusting the speed of the aluminum disc. So I said to you, so I consulted my friend to reduce my energy meter. What he has done, just he changed the position of magnet. He inserted more inside. Then what will happen? More brakes takes place. Then that's why the rotation is reduced. That's why I got the only 25 units out of 45 units. Okay, so this is a secret of changing the speed of the rotation. Okay, now the position of permanent magnet is adjustable, hence the braking torque is adjustable. Okay, so these are the braking system in a induction energy meter. Now coming to the last stage is this resistor system. Once it rotates, the disc also rotates, the spindle also rotates. The spindle there is a pinion and it is connected to the resistor system. So that will counts how many rotations takes place. Okay, so how many times you are rotating around the temple. So we are counting by using some small items. Suppose there is a 108 rounds or 11 rounds. So that is based on our counting. Similarly, that counts is counted by the one counter here. Okay, now registering system, registering and counting mechanism. So what is the main function? Record the continuously a number. So always there is a number 00, it records. The number is proportional to the revolutions made by the moving system. Okay, so whatever how many times is moved by the disc, that is always observed, and based on this one the counter will count the number of rotations. So there is one fixed mechanism. So what is it one? So it has a worm and worm wheel. So this is relating to the mechanical branch. Don't worry. Okay. The rotation of the spindle is recorded on the cyclometer. We can say that is a cyclometer. The ratio of the wheels are designed to give the energy for a set of revolution of the aluminum disc. So this is all mechanism taken care by the mechanical people. Okay, so this is one arrangement to record the things. If you want to see inside how the resistor mechanism so appeared outside, you can see it olden days. So these are different rate instead of 0, 0, 0. So inside how it will takes place, this one. Okay, so 1000 times, 100 times, 10 times, these are all mechanisms. Okay, now the gearing between the pointers. So 1.000, the 0 to 0, what is the mechanism takes place? Each pointer advances by 1/10 of a revolution for a complete revolution of the adjacent pointer on the main rotor disc in the train of gearing system. So dear students, don't bother about this regarding to the mechanical arrangement. Okay, so these are some important systems present inside the energy meter. How it will operate, we will see in the next class. let us summarize what we have seen in this class. A single phase energy meter consists of shunt magnet, okay, they are energized by the pressure coil, a series magnet energized by the current coil, and the flux produced by the current coil is proportional to and in phase with the line current. Here the flux phi 1 and I both are very good friends. And second case, the flux produced by the pressure coil phi 2 is proportional to the voltage. These are the good friends, but there is a conflict between the in ideas and lags behind the supply voltage by 90 degrees. Okay, so these are the another sum. The position of the copper shading band is adjustable. We can move this one center limb, the shading ring up and down such a way that we can create the disputes between our voltage and phi to 90 degrees. What is the purpose, sir? To produce the driving torque. Okay. The position of the copper shading band is adjusted to bring the flux of pressure coil in quadrature with the supply. The aluminum disc rotates on a steel pivot. The braking magnets are placed at the edges of aluminum disc only. The recording mechanism consists of worm and worm wheel. The rotation of spindle is recorded on the cyclometer. Okay, so these are some topics regarding the single phase induction motor. Dear students, I think you have some idea about how the energy meter records, works, consist inside the number of systems. Okay, we will see the operation in the next class. Okay, so thank you for listening my class, dear students.